Dissolution testing is a performance testing for the formulations and selection of the dissolution media. Selection of the dissolution media as buffer solution is very important and critical in the dissolution method development. This video is regarding the buffer solutions used as the dissolution medias. Welcome dear viewers to this video and let's start for the learning. Dissolution media is a medium or media in which the drug solubilization and drug release takes place. The actual formulation is exposed to the media, and in this media drug get dissolved, drug get released from the formulation. The critical excipients, pH dependent polymers or pH independent polymers also get dissolved or get swelled, or the excipients also get released from the formulation in the dissolution media. Dissolution media as buffer solutions simulate the physiological conditions of the human body and used in vitro testing to assess the drug release rate. The buffer solutions helps to predict the in vivo performance of the oral formulations. As we know that dissolution testing is a in vitro testing to predict the in vivo behavior of the formulation. Selection of the dissolution media and specifically the buffer solution as a dissolution media is very vital, important and critical. The media mimics the GI pH environment. It impacts the solubility of the API, solubility of some critical excipients, and dissolution and drug release from the formulation. The media should meet the sink condition requirement. The media should be sufficient in volume to provide the sink conditions. It is essential for establishing the IV-IVC, that is in vitro in vivo correlation, and the buffers are used in the method development and regulatory studies. We will see various types of buffers used as dissolution media. So you might be aware about the phosphate buffer solutions. Commonly, phosphate buffer solutions are used as buffer solutions for the dissolution testing. It simulates intestinal pH or systemic pH. The phosphate buffer has a pH of around 6.8 or 7.4 in general. It is a typical pH and it is mainly used for the BCS class 1 and 3 drugs which are highly soluble. Acidic buffer solutions, these simulates the acidic stomach conditions. Typical pH is 1.2 or 4.5. You might have seen or might have studied the dissolution in acetate buffer pH 4.5. The acetate buffers are useful for weak base drugs to assess the stability and the release. As the oral formulations after swallowing goes to stomach and disintegrate there or may not disintegrate there and then travel to the lower intestine with basic pH or neutral pH. That's why the buffer solutions are prepared with this pH range. Another buffer solution is citrate buffer solution. It mimics small intestine pH conditions and typical pH is 4.5 or 6.8. And citrate buffer is an alternative to phosphate buffer for solubility sensitive drugs. Tris buffer, you might have heard regarding the Tris buffer solution. It is used to simulate the neutral body pH. Typically, it has a pH of 7.4. It is less common but suitable for the specific stability needs. Then another is Macqueline buffer solution. Macqueline buffer solution is a mixture of citric acid and disodium phosphate, and it can cover a wide pH from 1.2 to 7.4, and it is a versatile buffer solution for evaluating the dissolution testing or dissolution across the GI tract pH conditions. Then simulated gastric fluid. It simulates the fasted stomach conditions. pH is 1.2. It is acidic pH condition. It may or may not contain enzyme used for the acid labile drug testing. Simulated intestinal fluid SIF, that is the media which mimics fasted intestinal environment. Typical pH is 6.8, may contain pancreatine as an enzyme. It is critical for the enteric coated formulations and delayed release closest forms. Then fed state simulated intestinal fluid. It simulates postprandial intestinal conditions. Typical pH is 5. It contains bile salts and lecithin. It is used to study the food effect on drug dissolution. Then fasted state simulated intestinal fluid FASIF. It simulates fasted small intestine condition. It has a typical pH of 6.5. It contains bile salts and lecithin. It mimics drug behavior in the fasting state and the fasting state intestinal environment. These are the various buffers used for the dissolution testing. The particular pH and the buffer solution, composition, ionic strength is finalized and evaluated based on the thorough study, dissolution testing, the properties of the API, solubility of the API, sink condition and sink factors, physiological relevance, PK of the drug, formulation composition, and many other things. In this video, there is a list of buffers which are generally used for dissolution testing. The selection of the buffer is critical in the dissolution testing, and it provides you valuable information and helps in the biorelevant dissolution profile development. It supports regulatory submissions and formulation optimization. The buffer solutions can provide you valuable information for the bioequivalence testing and in vivo behavior of the formulation. Now, once again, you can go through the buffer solution types and their typical pH. Phosphate buffers have intestine or systemic pH 6.8 7.4. Acidated buffer mimic the stomach environment with pH 1.2 to 4.5. Citrate buffer mimics the small intestine condition pH 4.5 to 6.8. Tris buffer provides the simulated condition of body fluid with pH 7.4. Macqueline buffer has a broad pH range and it can mimic GI tract pH 1.2 to 7.4. SGF and SIF are there for the stomach fasted state and intestine fasted state. SGF pH is 1.2, SIF pH is 6.8. FASIF and FASIF, that is intestine fed and intestine fasted. So intestine fed 5 pH, intestine fasted 6.5 pH. So this is the information regarding the buffers. Whenever you are performing the dissolution testing, understand the buffer composition, buffer pH, and why that buffer solution is selected. Always you should have a rationale for the selection of the dissolution media. Thank you for watching the video. Let's meet soon with another informative video. Thank you.